A pristine conceptual model is elegant in theory, but watch what happens when it collides with physical infrastructure. Logic scatters and system integrity collapses. Domain objects do not exist in a vacuum. From the moment they are instantiated, they enter a complex life cycle of creation, active modification, persistent hibernation, and eventual retrieval. Navigating this life cycle presents a severe challenge. The system must enforce the business rules, the invariants, across constant, unpredictable state changes. Concurrently, the technical mechanics of memory management and database mapping threaten to bury the core domain logic under a mountain of structural boilerplate. When strict boundaries fail, developers inevitably write business rules directly into database transactions or application services. The domain model is hollowed out, leaving behind nothing but anemic data structures. To protect the heart of the software, the domain object lifecycle must be explicitly isolated. We achieve this by implementing 3 specific structural patterns: aggregates, factories, and repositories. Without these 3 structural firewalls, even the most carefully constructed domain model degrades into a fragile, data-driven schema. Most business domains are highly interconnected. If we allow object graphs to tangle indefinitely, a single data update can trigger a cascading chain of validations. Transactions span unpredictable lengths, and invariants fail. We cut this tangle by establishing an aggregate, a cluster of associated objects treated as an indivisible unit. Every aggregate has a boundary and one root acting as the sole entry point. External objects are completely prohibited from referencing internal entities directly. Let's apply this abstract boundary to a concrete routing system to test the logic. This diagram illustrates a cargo domain. Notice the explicit boundary around the central cargo entity pulling delivery history inside. Entities inside operate on local identity. A specific delivery history holds absolutely no meaning outside its parent cargo object. By forcing all access through the cargo route, we gain total control over the object's invariants. Whenever a change is committed, we guarantee that all internal business rules are perfectly satisfied. To ensure scalability and avoid database locking issues, a single system transaction should only ever modify one aggregate at a time. Aggregate boundaries exist strictly to enforce business consistency requirements, never for database mapping or developer convenience. Once the boundaries of an aggregate are set, bringing it into existence is a highly complex operation. We don't ask the end user to weld the chassis of a car together, nor should we force the client application to assemble a complex software aggregate. Exposing the internal construction logic to client services risks creating invalid, half-formed objects that violate our carefully designed invariants. We encapsulate this creation logic using the factory pattern. This is an abstraction whose sole responsibility is to instantiate complex objects, keeping the intricacies hidden from the client. Simple entities can still use basic constructors, but complex aggregates with deeply nested relationships and strict consistency rules require a dedicated factory. The factory must execute as an atomic operation. An object can never leave a factory in a broken or inconsistent state. Factories also handle reconstitution, pulling an existing dormant object out of a database and reassembling it into active memory requires an entirely different set of logic than creating one from scratch. While a factory contains no business behavior itself, it acts as the necessary gateway, ensuring that no invalid state ever enters the domain. After an aggregate is created and modified, it has to be stored. But we cannot let the domain layer become contaminated by SQL queries, ORM frameworks, or data table logic. We solve this with the repository pattern. A repository provides the illusion of an in-memory collection containing all objects of a certain type. There is a strict rule governing their use. Repositories may only exist for aggregate roots. You never create a repository for an internal entity. This diagram shows the restriction in practice. By isolating the repository to the cargo route, we force the entire system to respect the transactional boundaries established earlier. The repository interface defines standard capabilities for interacting with storage, retrieving objects by unique IDs, adding new routes to the collection, and removing obsolete ones. In practice, there is always friction between an object-oriented domain model and the rows and columns of a relational database. Persistence requires technical compromise, but the database schema must never be allowed to dictate the shape of the domain model. Repositories lift that technical burden entirely. By delegating storage mechanics to the infrastructure, the client and the domain layer can continue speaking purely in the language of the business. Together, the factory, aggregate, and repository form a continuous, closed-loop pipeline for domain objects. The factory initiates the object's life. The aggregate guards its invariants in active memory, and the repository manages its hibernation and retrieval. When teams fail to understand this triad, they inevitably build one of 4 common architectural antipatterns. The giant aggregate. Drawing a boundary around dozens of entities creates massive cross-transactions, destroying database concurrency and system performance. The anemic aggregate. Shrinking the boundary too much leaves the model exposed, failing to protect business invariants that span multiple related entities. The CRUD repository. Generating a repository for every single database table violates the root requirement, exposing internal entities to direct manipulation. The internal query. Injecting a repository inside an aggregate to run live queries breaks the separation of concerns, bleeding infrastructure back into the core. By strictly enforcing the lifecycle pipeline, engineers decouple the complex heart of their software from the crushing weight of infrastructure, enabling true, scalable, domain-driven design.